right? Okay, so let us discuss about the mechanism of adsorption. Mechanism of adsorption. Mechanism of adsorption, right? So already you know very well about the adsorption phenomena. So okay, what is that adsorption phenomena? Adsorption phenomena is a surface phenomena in which there is an interaction between bent and bait. Okay, so bent, adsorbent, and bait, adsorbate. Okay, and also absorbent, and also absorbate. So once again I am repeating about the adsorbent and absorbate, okay. So I am pressing here add, and here it is ab. Okay, so adsorbent means only it is interacting up to surface rather than bulk phase. Okay, so here absorption, here, so it is interacting up to bulk phase rather than surface, that is the differences. Okay, so I am taking example also. Absorption, it is interacting, the interaction between absorbate and absorbent up to that surface only. This is all together is a surface. Okay, in between surface, this is bent, this is bait, this XX cross is a bait. If interaction is only there at the surface, that is called adsorption. Same thing, I am taking bent. In that bent, interaction inside also there, inside is there, that is what ab means inside, ad means outside. Just you see, if you take the any lotion only or any medicine up top of the body is a adsorption. If you take same medicine inside the body, is called it as a absorption. Okay, so if you come to the air particle touching at the surface of your body is called adsorption. It will going on inside your, by breathing it will going inside also is called absorption. Ab and ad. Okay, that is the difference of pronunciation, right? So and also we can take these things with the silica gel. You take the silica gel. What is that? Silica gel. So you take the silica gel. So that silica gel we can easily understand what is interaction. Then just only dry air will interact first at the surface of the gel. After that it will going on inside also. That's why it is called it as a, earlier it is adsorption, after that it is a absorption. If two things happen, it is called it as a sorption. Okay, some cases it will happen or some cases it's not. Okay, so based on the nature of the interaction. So now come to the point, mechanism of the, what is that? Mechanism of the adsorption. So there are interaction between adsorbate and absorbent. It is my bent. So now I am taking, this is my bait. Okay, this is my bait. Okay, so if in between them, when the interaction, the number of interactions increased, then automatically the randomness decreased. So why it is decreased? Randomness decreased. So earlier the surface is free. The surface is completely free. So they can accommodate very freely, very easily. So when you increase the number of components attacking, then automatically the bent and bait, in between bent and bait, there should be a congestedness. Okay, so when the congestedness increase, the randomness of the components are decreased. The randomness is called it as a entropy. So entropy. So if entropy decreases, then delta S is negative. So when delta S is negative, delta G also negative. When delta G is negative, delta H also negative. So here delta H, delta G is equal to delta H minus T delta S. T delta S. See, if delta S is negative, this is negative. So more negative plus less delta H. So more negative is more, positive is less. Then total is what? Summation is what? Negative only. So if delta H is negative, the negative minus negative, delta G also negative, thermodynamics very well. Okay. So here don't confuse. If delta S is negative, negative don't multiply. Here, my dear students, here not a multiplication. Minus into minus, it will be positive. How delta G is negative? You will ask question. No, here not a multiplication. Delta S is negative means its multiplication with temperature also negative. That's why delta G is also negative according to this Helm voltage gives free energy. So Helm voltage is also negative, delta H also negative. That is what our enthalpy. So enthalpy is also delta H also negative. So delta H is negative means is a exothermic reaction. Is a exothermic reaction. So why adsorption is always exothermic? Because when the interaction of bent and bed increased, the randomness will be decreased. Why randomness decreased? The accommodating particles are increased, then automatically congestedness increased. So when the congestedness is increased, then automatically attraction forces are very, very less. So then attraction forces are very, very high. So due to that attraction forces, the randomness will be decreased. Randomness is what? Entropy. Entropy is what? Delta S. Delta S will be negative. When randomness decrease, delta S will be negative. So then delta S will be negative according to Gibbs free energy. Delta S will be negative means delta G also negative. When delta G negative, then altogether it will be delta H also negative. So delta H negative means is an exothermic reaction. So that means adsorption is one of the exothermic reaction. There is a question. So why adsorption is always an exothermic reaction? Yes, is an exothermic reaction because the interaction between adsorbent and adsorbate, when increased, the randomness of the components will be decreased. When the randomness of the components decreased means entropy decreased. When the entropy decreased means that is delta S is negative. When delta S is negative, delta G also negative. When delta G negative, delta H also negative. So based on that condition is always one of the exothermic reaction. Okay, right.